Okay, we begin our section on related rates. These will all be word problems. Some will be easy, some will be difficult. Anytime I get these word problems, I always draw 4 boxes. And it says the area of a circle increases at a rate of 20 inches squared per minute. The question is, at what rate is the radius increasing when the radius is 5 inches? So in this first problem, we're going to take a little bit of time. We're going to try to get some context about what it's talking about, what we're trying to find, and hopefully this will help you better understand what we're trying to accomplish in these type of problems. The circle is getting bigger. So tell me some things that are changing with the circle. The radius is changing. What else is changing? Diameter, circumference, area. These are all things in the circle that are changing, right? And because they're changing, they have a rate. And they are all related to a very specific thing that's changing that's not up here on the board, and that is time. So all of these variables are related to the change in time. Okay? Now, I'm going to make a little chart here. I'm going to talk about time. I'm going to talk about the radius. I'm going to talk about the area. So we'll say at time 0, we have a radius of 0 and an area of 0. At time is equal to 1, 2, 3, 4, 5. Okay. At time 1, I don't know the radius, but I do know the area. What would the area be? The area is 20. Why did you get 20? Every minute, it goes up by 20. So the area is increasing at a constant rate. So at 2 minutes, or at time 2, the area would be 40, 60, 80, and 100. Now, given the area, could you go back and find the radius? Okay, so here's what I'd like you guys to do. Okay, U3 right here, I would like U3 to find the radius when the area is 20. Give it to me as a decimal to the nearest hundredth. Don't express it in terms of pi. I would like U4 to find the radius at 40. Okay, I would like U3 to find the radius at 60 minutes. Like U2 to find it at area of 80, and like U2 to find the radius at area of 100. Okay. So what is the formula for the area of a circle? Pi r squared. So simply set your area equal to that and solve for the radius. We'll collect some values up here, and we'll talk about what we get. Okay, so let's look at this situation. As you look at it, is the radius going up, or is the change in the radius going up by a constant amount? No, it's not. First it goes up by 2.5. Then it goes up by about 1, then it goes up by about 0.8, then it goes up by about 0.64, something like that, and then it goes up, goes up by about 0.6, right? So would you agree that, it looks like it might go up by another 0.6 or 0.5, something like that? Okay, so we would say that r prime is going to be less than 1 inch per minute, right? It's going to be less than 1. We would say it's probably going to be somewhere between 0.4 and 0.8, somewhere around there, right? And so that's what we're trying to figure out. Now, it would be challenging to simply make table values and guess all the time. We can use calculus to find this answer pretty quickly. And what we do is we set up a formula. So I draw the picture here, and then the formula is area is equal to pi r squared. And in this box, I usually write some of the things that I know and some things I don't know. For example, do you know r prime or a prime? A prime is 20. Do we know, because the area increases at a rate of 20 inches squared per minute. So the derivative of the area is 20. Do we know the current radius? Does it tell us what the current radius is? current radius is 5. As you notice, it's asking for at what rate is the radius increasing. So I'm looking for r prime. That's what I don't know. So what I'm going to do now in this box is I'm going to take the derivative with respect to time of a equals pi r squared. Now, when you take that derivative, note that it's different here. You have t as your variable. So when we used to try these problems, we would say we're going to take the derivative with respect to x of x squared plus 3y to the third is equal to 4. What was the derivative of x squared when we're taking the derivative with respect to x? 2x plus 9y squared y prime equals 0. So notice anytime you had a variable that did not have an x with it, you attach that y prime. Well, notice in this situation, I'm taking the derivative with respect to time. Does t pop up in here at all? So every time I take the derivative of a variable, I have to attach an a prime or an r prime or anything like that. So the derivative of a is 1 and attach an a prime. Pi is just a constant, it's not a variable, so it comes along with us. What's the derivative of r squared? 2r, so I have 2 pi r times r prime. I have to attach an r prime. Every time you take the derivative of a variable that doesn't have a t, you have to attach a rate of change to it. So I have this formula. A prime is equal to 2 pi r prime. And maybe now at this point, maybe now we can plug in some values and solve. I know that a prime is equal to 20 is equal to 2 pi times the radius, 5, times r prime. So we divide both sides by 10, we would get 2 is equal to pi r prime, or 2 over pi is equal to r prime, or 2 over pi. What is our label? We're measuring a radius. As a radius can be measured in inches, inches squared, inches cubed. Just inches because it's one-dimensional. So it looks like we're inches per minute. Okay. Now, if you convert that to a decimal, we take 2 and we divide it by pi, you can see you come up with that 0.6 value, which we thought was somewhat close to what we were going to get, right? Yeah. All right. So we found the exact value, 2 over pi. Let's move on, example 2. A basketball is being filled with air. What's the difference about this problem? We have a sphere, which, you know, that's my best sphere. There you go. The sphere is getting bigger. So I'm looking for the formula for volume of the sphere. And volume is equal to 4 over 3 pi r cubed. It says it's being filled with air at a rate of 1 cubic centimeter per second. At what rate is the radius increasing when the radius is 12 centimeters? So what givens do we have? What are we given? The radius is 12. What else are we given? V prime is 1. Those are 2 things we're given. What are we trying to find? R prime. When we take this derivative, will we come up with an r prime? Yeah, we will. So let's take the derivative with respect to time. Derivative of v, v prime. Derivative of 4 over 3 pi r cubed. R prime. So that's my derivative. V prime is equal to 4 pi r squared r prime. And we know v prime is 1. we know that the current radius is 12. Four times pi times 144, 12 squared. One divided by the answer, and I get, 1 divided by 1,809.56. And I get 0.00055 watt. What's my measurement in? Because I'm looking for radius, we won't be centimeters cubed, but just centimeters and times in seconds. So that's equal to r prime. So you could have, yep, exactly. Yep. So if you want to leave it in terms of pi, it would be 1 over 576 pi centimeters per second. Okay, we're going to pause there. Okay, as we move ahead to problem number 8 here, it says the volume of a ball is increasing at a rate of 10 cubic centimeters per second. At what rate is the diameter increasing when the volume is 100 cubic centimeters? Oh, I shouldn't say per second, it's just 100 cubic centimeters. My bad. Okay. So again, we have a sphere, and the surface area of a sphere is 4 pi r squared, but we're talking about volume here. Volume is 4/3 pi r cubed. And it is getting bigger, okay? And so we have a lot of things that are changing. What are we given in the problem? We're given v prime is 10. We're given v is 100. What is it that we are trying to find? At what rate is the diameter increasing? Therefore, we are looking for d prime. Now, if I were to take the derivative of the equation I have right here, would I come up with a d prime or an r prime? Well, that's problematic, isn't it? So maybe I could write an expression for d. Isn't the diameter equal to 2r? Or in other words, r is equal to 1/2 the diameter. So we've always written volume of a sphere to be based off the radius. Let's write it so the volume of a sphere is based off the diameter. So volume is equal to 4/3 pi times 1/2d cubed. So volume is 4/3 pi. 1/2 cubed is 1/8. And if we simplify that, we get volume is equal to, going to have 4 pi over 24, or pi over 6. Pi over 6 d cubed. Caleb? Okay. So let us take the derivative with respect to time. We get v prime is equal to pi over 2 d squared. Which part? The derivative of v is 1. Attach a v prime. Drop the 3 in front. I get pi over 2 d squared d prime. So I have v prime is equal to that. I know that v prime is equal to 10. Do I know the current diameter? Oh no. What do I do? Find the radius? How? What's the volume? Volume's 100. Can't I just set that equal to pi over 6 d cubed? Won't that give me the diameter? Very good. So let's do it. I have 100 times 6 divided by pi. Then I will take that answer to the 1/3 power. And I get 5.76. So the current diameter is 5.76. Because I'm trying to get rid of the 3, so I have to cube root. So cube root will be 1/3 power. So I have 5.76 quantity squared. So we'll take that 10, we'll multiply it by 2, we'll divide it by pi, and we'll divide it by 5.76 squared. Okay, 0.19. And my measurement is, in this problem, centimeters per second. So this one was unique in that we had to solve for another variable because we weren't going to come up with r prime. We were going to come up with we weren't going to come up with d prime. So therefore we had to insert diameter. Okay, one more example. Move back to problem number 3. A right triangle has a base of 12 that remains constant while the height increases. Obviously, the hypotenuse will increase, and the overall area is then going to increase. What is my formula for area? What do I know? Base is 12. What else? Area is? A prime is 8. What am I looking for? H prime. If I took the derivative right now, what rule would you have to use? Product rule, Catherine. Why? Yeah, B times H, right? So you'd have to use the product rule. However, I don't have to do that in this situation, and there's a certain reason why. We have to consider what's changing. Is the height changing? Yes. Is the base changing? No. Since the base is not changing, since it remains constant, we can plug in the 12 right now. Don't do that in most situations. If you remember from our very first example, the radius was 5. But it wasn't 5 all the time. If it is 5 or if it's 12 all the time, then you can plug it in. I'll show you how it works out. But right now, let's solve this. I have area is equal to 6h. I will take the derivative with respect to time. What is the derivative? A prime is 6 H prime. So A prime is 8 is equal to 6 H prime. So 4 over 3 is equal to H prime. Or 4 over 3 looks like centimeters per second. Watch how I work this out using the product rule. A prime is equal to, what's the derivative of 1/2 B? 1/2 B prime times H plus 1/2 B times the derivative of H, H prime. Now as you work this out, is the base changing? No. So what is B prime if the base isn't changing? At what rate is the base changing if the base is not changing? 0. So this whole piece here goes away, doesn't it? And you're left with this expression, and we know that the base is 12, so you're left with 6H prime, which is exactly what we have, right? So that's why it works out in that situation. You see that? So some interesting pieces about that. So what you can do right now is by tomorrow, you should be able to do problems 1 through 7 on your related rates problems. The answer keys are online. The answer key is posted right there. We are going to get to problems that are definitely more challenging. But I want you to work on these, feel confident about them. These first 7, you should feel like, hey, no issues at all. As you notice, they're divided up into 4 levels. You're working on level 1 and just one of level 2. We're going to get to more challenging problems tomorrow. Shout out to Maddie and Bree. We miss you guys. However, it's a lot quieter with you gone. So, exactly. Bree, we hope you get better soon. You too, Maddie. So, see you guys soon.